3.3 Increasing and Decreasing Functions. Let's now talk about intervals where a graph is increasing and where the graph is decreasing. For a graph that's increasing, all the slopes in this interval are positive because the graph is moving up. Therefore, we know that within the increasing interval, the derivative must be positive. If the function is decreasing on a certain interval, the slope, and therefore the derivative, must be negative while the graph is moving downward. As you should remember from 3.1, a plateau is the flat part of a graph. At a plateau, the graph is neither increasing nor decreasing. The first derivative test tells us if a critical value is a maximum, minimum, or plateau, and we can find out where the graph is increasing and decreasing. This test uses a sign chart, which is a helpful tool when finding extrema. Basically, it's in this structure. The critical values, including endpoints, break up the number line, and boxes in between show us if the derivative is positive or if it's negative within that interval. If it's positive, we can see that the graph is increasing. If it's negative, the graph is decreasing. This is found by just testing a value within each of those intervals into the derivative function, which you found before. In addition, we can determine extrema using patterns in sign changes. For example, increasing to decreasing, or positive to negative, means a maximum is at that point. Decreasing to increasing, or negative to positive, means a minimum, and no change at all in the sign or direction means a plateau. Let's try some examples. In this example, you have to use the first derivative test to find extrema and find the intervals where the graph is increasing and decreasing. We'll have to take the derivative and set it equal to 0 to find critical values. In this case, we can find f prime of x using the power rule. F prime of x equals 3x squared, and when we bring the power of 2 down, it just becomes 3 times 2 over 2, leaving us with 3x. Now we can factor out a 3x, giving us 0 equals 3x times x minus 1, and giving us critical values of x equals 0 and x equals 1. Now we must test these critical values to see whether they are maximums or minimums. To do that, we must use a sign chart. Let's draw a number line and put on it the points 0 and 1, drawing boxes split at those points. Now we have to test values within those intervals to figure out whether the derivative is positive or negative. So for the first interval, we can try f prime at negative 1. That gives us negative 3 times negative 2, giving us a positive value of 6. Therefore, we can say that it's positive within that interval. Within the next interval, we can test f prime at 0.5. That gives us 3 halves times 0.5 minus 1, which is negative 1 half, giving us negative 3/4, making that interval negative. Finally, we can test f prime at 2, giving us 6 times 1, which is positive 6, giving us another positive. Therefore, we know that the graph is increasing, decreasing, and then increasing again. Now we can say that there is a maximum at x equals 0 because the graph goes from increasing to decreasing. There's a minimum at x equals 1 because the graph goes from decreasing to increasing. We can also say that the graph is increasing from the interval negative infinity to 0 and in the interval from 1 to infinity, and it's decreasing in the interval from 0 to 1. Let's try another example using the same process. First, we have to take the derivative and then set it equal to 0 to find critical values. In this case, f prime of x is equal to 12x cubed minus 12x squared. Now we can set it equal to 0 and extract a 12x squared to give us 0 equals 12x squared times x minus 1, giving us x values of 0 and 1, and these are our critical values. Now we have to make a sign chart to verify these critical values. Now we split it at x equals 0 and x equals 1 and make the boxes. Let's test values. F prime of negative 1 is equal to 12 times negative 2, which is negative 24, and that's a negative value. F prime at 0.5 is going to be a positive times a negative, giving us a negative overall and making that interval negative. Finally, f prime at 2 is going to be a positive times a positive, which gives us a positive overall within that interval. And now we can say that the graph is decreasing, then decreasing again, and then finally increasing. So therefore, there is no maximum, but there is a minimum at x equals 1, and there is a plateau where the sign does not change at x equals 0. We also know that the graph is increasing from the interval from 1 to infinity, and the graph is decreasing at the interval negative infinity to 0 and 0 to 1. And that's our answer.